All right. So I'd like to see a quick show of hands, just so I know who I'm talking to here. Can I just see, like, who's a beginning programmer just starting to get into learning to code? Hands up high. Yes. Awesome. Yes. Who is junior developer, maybe like actually doing it for a living, but first few years of your career? Good. Yeah. Who's an experienced developer, whatever experience means to you? Been doing it for a while. Good. So we have a nice mix. Is anybody teaching programming in here? Yeah. Nice. Okay. Sweet. And who's in or very recently in college right now? Who's in or recently in a boot camp? Okay. Cool. Code camp, whatever you want to. You know what I'm talking about. Great. This question is ridiculous. I phrased it to be ridiculous, to get us thinking. Obviously, there is no single one right way to learn and teach programming. But what I want to talk about today is my perspectives on ways of approaching learning to program that are useful to me in hindsight, things that went well and didn't go well for me. And like I said, I mean, I know this is a big room, but please do interrupt me with questions. I want to hear your thoughts. I left a little wiggle room in this talk, and I'd like you to steer me to things that are interesting. So please speak up. Don't be shy, even though I ran out of CDs. So when we talk about learning and teaching, our thought usually goes to school. In particular, we usually think of what skills am I going to learn in school? The title of the talk, I think, would touch off for most people thoughts of, well, what's the right language to start with? And what's the right kind of school to go to learn that language and that set of tools? The main goal of this talk is to broaden your thinking away from that, because that's a useful question, but I don't think it's really a particularly important question. So a way of framing this that maybe gets us thinking a little bit better about it, draw that circle, that's school. And now there's a bigger circle, which is education. Not all education happens in school. Some education is self-teaching. Some education is ad hoc experience. Some education is bitter experience. Some education happens on the job. What do I mean by education? I mean, well, let's contextualize it a little more. Education is part of learning, but not all learning is education. Today, you've been learning where the rooms are at Best Buy. You walk into this room, your brain is learning all the time, right? You kind of learn the pattern of the wavy lines on the side of the room without even thinking about it. That's learning too. A lot of learning is not education at all. It's just like patterns and thoughts that your brain picks up because your brain is alive and it fades. Right. So what is education? Education, I would say, is learning with some kind of lasting value, maybe even learning that is central to who you are as a person, learning that you yourself value over time. And ideally, school is at the center of that, but school is not your whole education. In practice, the diagram often looks more like this. 7th and 8th grade were pretty much this. Like I learned a lot of stuff that was not educational. A lot of it was there was no learning at all. My brain was off. I was bored out of my skull, right? But at least in an ideal world, school is at the center of education. So the question, what's the right way to learn and teach programming? It doesn't have to be a single answer. It's not just about what kind of school you do. Think about all the things that you learn to write software. And then out of those, which ones are really valuable education, right? So what kind of learning is valuable education for writing software in or out of school? To get at that question, I'm going to talk a little bit about my history and experience as a developer and just some things I've noticed about what software is like in practice. I would like you also, please do jump in. You're doing a really bad job of interrupting me right now. Jump in with amens or no, what, are you kidding? You know, just tell me about your experience too. Yeah, nice, thank you. I've worked at a bunch of places over the years. That's just to give me an air of credibility. I've I'm a freelance software developer and sometimes professor at Macalester College. So I teach computer science, I write software for clients. I have over the years worked full-time in a variety of companies, done contracts for a variety of companies. I've seen Fortune 500, startups, everything in between. I've seen the good, the bad, the dumpster fires. You know what I'm talking about. Right. I take it I'm not the only one. The dumpster fires were great education, by the way. I think of a place which will go unnamed, but it's the same as the Hungarian name for radish, if you want to look that up, where there were a lot of dumpster fires, and that was great education, and none of it was about technology. Because here's the thing about software. Software is written by people, with people, for people. Software is intensely social. And I say this as somebody who teaches computer science. Software is not just about code. It's about why you're writing the code you're writing. Who's reading that code that you're writing? Who's adding to it? Who are you working with? Who are you writing it for? Who's going to interact with the results of that code? In, around, and through everything about coding is humans. Like computers are humans. They're layers and layers and layers of humans. When I look at a user interface, I see all the people who made decisions about like which pixel will line up with what other pixel, and what's the memory allocation scheme, and why did we choose to include or not include that feature. It's people all the way down. And when we use software, we like to think of computers as being this sort of other, the sci-fi trope of the AI that takes over. This thing that exists outside of humanity. I mean, computers are the product of humanity. Even these beautiful abstractions, the most mathematical parts of computers, those are human dreams of mathematical beauty made real in a computer. So my first observation about learning and teaching software is that we can't separate it from people. If you want to just learn to write code and make code that goes, maybe that's mostly theoretical, but a lot of what we do as developers is about thinking about code with other people, writing it for people. Just to make that slightly more concrete, there's part of the reason I think software estimation is often incorrect is that we imagine when we're estimating what seem like a bunch of similarly sized tasks. Yeah, thank you. It should start showing. Oh, there we go. You see the little line there? Here's a task, right? Here's actual time taken for a task. That was good, thank you. We think that software tasks are going to go like this. We thought they'd be about the same size, and maybe we were a little high and a little low, but they kind of chug along with a kind of normal distribution of difficulty. Right? In fact, what actually happens when you're writing software is that tasks turn out to be like easy, really easy, oh, crap. Wait, what? Like I just wasted a week searching Stack Overflow and finding out that this library just can't even do the thing I thought it did, right? And then things go along easier and easier, and then, oh wait, here goes like a month because it turned out we were building the wrong thing. There was all this awesome development that just went into crap, and we have to throw it all away and retrench, right? And then it goes along easily, and then there's just a few of these sort of huge spikes. Statisticians in the audience, I think that individual software tasks form a log normal distribution of difficulty, not a normal distribution, or Poisson, I guess it doesn't go below 0. And the way that you make a software project go faster, I think the thing that a really experienced, excellent developer brings, we imagine that the awesome developer who has 5 years of experience, 10 years of experience, we like to think that they do everything just a little bit faster, like from this to this. They just shave a little off all the tasks. That's totally not what happens. What actually happens is that the awesome developer mostly takes the same time as anyone else to do things. The difference between 5 and 20 years of experience, for most tasks, it's not that big, except the really awesome developer says, you know what, we don't even have to solve that problem. And here, look, we're thinking about this in far too complicated a way. We can rethink this problem in a way that turns it into something easier. A really awesome developer maybe can just shave off a few of those spikes. That's why some teams make software much faster than others. So what's the difference there? The difference is not about just technical mastery of the language. It's about technical mastery paired with an ability to think about the what, the who, the why. Are there social problems that are undermining the team? Are we building the wrong thing? A lot of it is about listening to people very carefully. One of the classes that I took in college that I found most useful in my software career was a religion course called The Letters of Paul, because I was Paul and I was in St. Paul, and I thought I should take a class called Letters of Paul, right? It turned out, yeah. It was a great call, and also I knew that the prof was awesome, which is my advice to students, just like find the profs that you like and get what you can from them. It's all about the person teaching the class. Yeah. My first year RA's girlfriend told me, Paul, it's better to take nose picking 101 from an awesome prof than the best class from the worst prof. And it was such good advice. I stuck with that. Nose picking, great class. This was not nose picking, it was hard. So what we did in the Letters of Paul was we read Paul's letter to the Romans, right? It was a religious studies class. It's this thing from the New Testament. I'd never really looked at it closely before. I'm not a theology expert. We went through that thing like 2 or 3 sentences a week. And we read everything that any commentator for the last 400 years had said about what those few sentences might mean. And I spent the whole semester thinking really, really hard about the question, when another human being uses these words, what are the thoughts in their mind? Right? That was fantastic practice for software, because our job as a developer, our job is to take vague ideas and make them incredibly specific. Specific in a way that's almost impossible to imagine if you haven't written code. And that difference between the big spike and the small spike, often it comes down to, we thought we understood each other, but I was imagining one thing and you were imagining something else, and we just wasted 2 months building the wrong thing. Like that's an actual thing that happens in sync software projects. Being able to pay very close attention to the words that other people are using and just reason about what they're thinking, I would say is an example of something that's important to software education. Right? This is even true of code. I mean, if you're kind of thinking to yourself like, yeah, but software is mostly code. I mean, here I just grabbed a bit of code from one of my open source projects. There's a lot we could say that's technical about this code. It's Swift. The braces are funny. Deal with it. There's a lot that's technical we could say about this code, but there's also a lot that's human. Code is written for 2 audiences, 2 completely different audiences, one of which is a human and one of which is a computer, right? A computer reads code according to the rules of the language. A human reads code with experience, metaphor, intuition, social understanding. Code is both a kind of writing that we do for other people and that we do for the computer. And one of the crucial aspects of good code is just that it should mean the same thing to these 2 audiences who read it completely differently. Right? So I can, pardon me, I have to set down the mic for this. I can make changes to this code that make it mean exactly the same thing to the computer, right? Like I could go through my program and just rename, wow, it didn't like that, did it? Let's see here. I can rename process response A, and this can be B, and this can be C, right? Like at the very most basic level, names are immaterial to the, right? Like I'm obfuscating this code. Like we actually have programs that do this. They try to make code mean the same thing to a computer and make it incomprehensible to a human. But even something as simple as choosing names, actually the hardest problem in computer science, something as simple as choosing names is about being able to synthesize technical knowledge and social knowledge. And so, for example, in this code, I chose to name this binding here custom response info to convey to people that this is a custom response, presumably as opposed to some kind of response that's not custom. Okay, wait, reader of the code thinks, why did he call it custom response? What is a non-custom response? Oh, it's probably this one right here. Sorry, I forgot to undo all my renamings. response info is different from custom response info. Why is that? What do these things mean? Somebody can start forming ideas about my intent, why I chose those things. They can even start to develop metaphors, which is what code is all about. Encapsulation is about building a metaphor for people to understand and a logical abstraction the computer can use. And those two things hopefully kind of line up. Like list is a metaphor, right? List is a thing that you can understand intuitively, and it's a thing that you can reason about precisely in a way that makes code make it make sense. So, and even like style decisions in the code, like using a guard clause here instead of an if-else in Swift. Guard means there has to be a return inside. So I'm sort of conveying that this is intentionally a branching off stop condition for the method. I mean, this is just like, it's a little thing that helps an experienced Swift reader make sense of this code, even though there's no comments even. There are comments up above. I have them hidden. It's extensively documented, blah, blah, blah. Right. So conclusion from that, what kind of education gives you that? And remember, it doesn't necessarily have to come from school. Well, one way of doing it, yeah? Yeah? Absolutely. Reading other people's code is awesome. That is such a good use of your time. In fact, I'm going to just, I meant to start a little running list of tips because I'm sure that many of you learning will want read other people's code. That is a great way to learn. Also, read things that are not code. Study how people communicate when they're not thinking technically. Yeah. So that's tough, right? Because what domain are you going to be writing software for? You're probably not going to work on the same application your whole career. That happens, but it's unusual. What that means is that you want to cultivate I'll indent this here. When you're thinking about your software education, make sure that you are comfortable learning new things quickly and often. Jumping into an unfamiliar domain, all of a sudden, healthcare, retail, I don't know, shipping, airplanes, volcanoes, whatever. There's volcano software out there, I'm sure. Comfort and confidence jumping into new things and learning them quickly is a part of your software education, and you're probably developing that, and it may not be in school. That's okay. One way of getting all of this together is to do like a big 4-year college program. Like this, what I'm describing here, this mix of things, like there's a name for this kind of education. We call it liberal arts education, and it's an awesome way to prepare for software. That's why I believe in and teach at a liberal arts college. There are other ways to get it. Another way to get it is to work in some other industry where you build some amazing social skills or communication skills or ability to pick things up quickly, and then go to a code camp and get some technical skills to mix with them. This software education circle, which parts of it fall inside school, can vary a lot from person to person, and that is A-okay. This ability to learn, I particularly want to emphasize, it applies to programming languages. I always get a little leery when I hear somebody define themselves as a PHP developer or Ruby developer, Java developer, even if you love the language and you write a lot of it. I went through Wikipedia's list of programming languages and just copied off every one in which I have had to do real programming. So some more than others. I know more Ruby than Python probably. XQuery, that was just one project where I really had to like actually learn it, and I've now forgotten it. The point of this is that, well, I've been programming for 30 whatever years, but this is more than one new language per year. In your software career, you're going to have to keep learning new languages. And if you think that your education is just about learning a language and then you're good to go, that's not going to last you for very long. The shelf life of learning a specific product, like I learned to write WordPress plugins. Good, that's an awesome skill. You should totally learn to do that. It's only going to help you out for a few years. Right? Learning a specific language or platform, that can help you out longer. Maybe a whole career, if you can stretch it. There are still COBOL programmers out there. But if you become afraid of learning new languages and afraid of jumping into new things, you will find yourself on a shrinking island, no matter how awesome the language is. Languages you love, languages you hate, either way, you're going to have to learn something new. So beginning programmers don't, that first language you learn, it's so hard. It's brutal. Programming is brutal to beginners. Right? It makes you feel stupid. And I mean everyone. It makes me feel stupid, and I've been doing it since 1982. And I feel like an idiot every day writing code. And it's normal, so I just stopped noticing it. But because we're human. But learning new languages does actually get easier every time you do it. Yeah. And you had your hand up maybe a little?
I think it's scary if you only know one specific thing.
Uh-huh.
But if you don't know one specific thing, that's even worse.
Yeah.
You do have to get to mastery in order to get to mastery into another genre.
Yeah, it's true. And so it's good to both delve into something right now and be ready to move on. And a related thought, that is a really good observation for beginners. Another piece of really specific advice that I have if you're learning to program is, set this down. Get a problem before you learn the solution. Get a problem before you learn the solution. Don't run out there and read the language's manual and learn all the features and think now, okay, I can use all the features. They probably won't make sense, or if you're a super genius, they'll totally make sense and you'll start using them all, which is even worse. If you're just wondering, where do I even start with this thing? Pick a problem. Problem could be a job, internship, thing you want to build in your spare time, tutorial, I don't know. Get frustrated, get your hands messy, need a solution. And then, when you learn about the language feature or the library or the platform that solves your problem, it'll seem awesome. Some advice that I got from my wonderful teaching colleague, David Brissou, amazing teacher, now just retired. David, so cool. He wrote a really beautiful review of a calculus textbook once, where he said, "This textbook moves beautifully from the simplest things to the most complex things, building up step by step in perfect, seamless beauty, which is its main problem, because you don't know why it's doing anything and you don't care. Here's the definition of a derivative. So what?" All right? Derivatives are awesome. As soon as you need a derivative and you see a derivative, you're like, oh my God, derivatives. What? Wow. But the frustration is the precursor to that. So if you're a beginner and you're frustrated, that is awesome. And my own personal history, I first learned to program when I was a kid. I was very lucky to have parents who turned me loose with a computer and nobody sitting over my shoulder telling me I couldn't or shouldn't. And I started programming because it was fun, which was great because it was really hard, but I didn't notice because I was having fun. Two things about beginning programming: it's really fun and it's really brutal. And the one of those two that you notice is going to dictate how you learn, which I think is one of the sources of the gender gap in programming, right? If you have society telling you, people like you aren't programmers, you start noticing how brutal it is. Yeah? And if you're having fun, and you have permission to have fun with it, you don't know it's hard. I didn't know it was hard. I looked back on learning a kid, I was like, wow, that was really hard. What the hell was I doing? How did I learn that? Yeah. Stick with the fun. Stick with the fun throughout your career. But what that means, part of it is, if you're frustrated, that's a good sign. Learning is about to occur. Jump into that frustration. And if you're not frustrated, get frustrated. Get a big enough problem that learning to code is going to give you that aha moment. That's when learning happens. Another thing closely tied to that, I think that learning to program is typing it one-handed. Wow, that's tricky. Experiential. I was close. It's experiential. You can't just read a bunch of stuff and then dump it out. You got to get your hands dirty. Got to get your hands dirty with it. So because of that, programming favors the bold. Bold, bold. The rewards are legion. If you're looking for your first job out of college, something to consider, look for a small shop, a nonprofit, a place you haven't heard of. I worked at NPR, Minnesota Public Radio, my first job out of college because I thought it sounded cool. And it was. And I was at the time, I was the only actual code slinging programmer. They had people doing HTML and CSS, but I was the only web developer. I didn't know what I was doing. I didn't even know how the web worked when they hired me. And it was 1999, and everybody was like, why does a radio station need a website? that was the thing once. But it was great, because they gave me way too much responsibility. I was doing something, I had no business doing what I was doing. And I screwed so many things up, and I learned so much. And it was great. They were happy. They had an enthusiastic person doing, greater than zero work on the website, and I was happy because I was learning things left and right. I mean, that was great experience. I saw a hand go up back there.
I was just going to go back to the point that you were making about frustration being a good sign.
Yeah.
Have you had much success convincing students to embrace that frustration?
I don't know, students, I see several of you in the audience. What do you think? Have you embraced frustration yet? Are you too shy to identify yourselves? Thumbs up, embrace frustration. Thumbs down, still frustrated. Yeah. Okay, cool. Yeah, it's getting there. Yeah. We'll get you there, Marie.
I'd like to add to that. I remember the same thing as you. I remember the frustration. And at that age, for me, like you, it didn't seem there.
Mm-hmm.
But looking back, right now, I wouldn't go back to do that again. I do not have the time to be frustrated the same way again.
Mm-hmm.
Google's my friend.
Yeah.
Not know who works, but Google.
Yeah, Google is a huge help. I wish we'd had it back in the day. Let me get this thought together. Yeah, it does, because you can get bad advice from the web, which is great education too. Like looking at other people's bad code on Stack Overflow is awesome. The top voted answer is not necessarily the best answer. That's a truism. What was I going to say? If you're getting into programming and wondering if it's for you, the advice I give on that is, if you're frustrated, that's okay. If you feel stupid, that's okay. We're all human, right? Programming makes absolutely everybody feel like an idiot, including me. But if in spite of that, you lose track of time when you're programming, you should continue. If you were frustrated and bollocks and hitting your face into your forehead until 3 a.m. when you'd meant to go to bed at 11, you should totally be a programmer. That's an awesome sign. Question in the back.
Are you talking about Zelda or programming?
Well, the overlap between gamers and programmers, I think, is not accidental. Games that are fun to play are usually fun because they're cognitively interesting in ways that are naturalistic. Well, why don't you know that? So a good game makes your brain light up all over. Your brain is like, wow, I'm thinking about this, and all these different parts of my brain are working together, and it's fun because I'm thinking cool, fun thoughts that connect to each other. That's games. That's also programming. And on that, I saw some other hands go up, so I'll get to them. I'm not forgetting you. Another huge piece of advice I give, especially if you're in college and you have the chance to do this, is in addition to studying code in school, which is a great thing to do, also study. Pass them down. Also also study. I'm not typing over the microphone. It's disastrous. Take a course that makes you sweat hard over your writing. It will pay off. Anything that makes you work to communicate, do not slide through the humanities courses. Choose the hard ones. Choose the ones that challenge you. You will not have another chance in your life after college to focus on this as well as you do in college, so take advantage of it. Also, just somewhere, at least once in your life, do something, music, poetry, painting, something, where you have to do creative work which stands or falls on aesthetics alone. Because in software, you end up making a lot of aesthetic decisions as a programmer. Even if somebody else does the design and they give you a design and it seems like it's all there to execute, you make tiny decisions. Exactly how should that animation bounce? Exactly how, a designer gives you a design, that's not the same as an algorithm for a layout. How should this layout behave for a slightly wider or smaller window than the designer gave me? You make hundreds and hundreds of teeny tiny little aesthetic decisions, even about how software behaves, how it responds to input, in almost all kinds of programming. And having just once thought hard about your own aesthetic reaction to the thing that you're building as you're building it will make you a much, much better programmer. And again, if you're in college or you have the opportunity to really focus in on something like this, do it now, because it's so much harder later in life. You really have to fight to do artistic work when you're employed. And if you're in an educational environment that gives you this, just grab it while you can. Okay, if you're not, find other ways to do it. Go take an art class for a while. Think of that Letters of Paul class. Things will pay off in ways that you can't anticipate. All right, I want to get to more hands. End of spiel. A couple of people had their hands up, and now I've lost you. I think you had one. Mm-hmm. Yeah, absolutely. And the funny thing is, we learn to sneer at school and hard work, but actually we love learning. Learning is fun. I don't mean that in some after school special kind of way. I mean it very literally. Our brains get tremendous pleasure from actual learning. It's a fun thing for our minds. We love to do it. The kind of cognitive flexibility that you cultivate from just constantly encountering new things and being hungry for them feeds back into being a developer. Are you all disappointed that I'm not talking a lot about languages and whether you should learn object-oriented or functional programming first? Because you can. There's no wrong way there except the way where you get calcified, set in your habits, don't pay attention, get so opinionated that you can't work with people. Those are learning mistakes. Learning a particular language first, even a terrible language. My first language was AppleSoft Basic. That's such a design disaster. It's awesome. It was great. I learned so much. Had a hand over here.
I think you might touch on it with the state up.
Yeah.
I'm just going to say, when is the frustration something to work through, and when is it maybe
It's a good question. Frustration means a lot of things. Sometimes frustration means that your colleagues are jerks and you need to get the hell out of there. And that's for real about that. And by the way, pay attention to that, for heaven's sake. If you're working with people who are, creeps or bullies, you don't have to put up with that. You have choices. You do not need to power through a miserable situation that's killing you in order to reach some kind of career goal. Take care of yourself. Get out of there, right? Really. Question?
So to add that many times I've had a situation where by stepping away from a complex problem, letting it simmer in the background while doing other things or some things completely unrelated, coming back to it the next day, that it just comes all the time. So frequent.
Yeah. There's actually good research that says that napping on a problem makes you solve it better.
Don't nap at work.
Yeah, well, or do if your employee's understanding. Although I had a friend who worked for Minnesota Mutual who had a nap room, and she took a nap in the nap room, and they chewed her out for napping at work. And she's like, "There's a nap room," and they're like, "That doesn't matter." So we're back to the toxic environment. So yeah, Marie, right there. Yes, Marie.
This is probably a topic we can do an entire other talk on, but thinking about both what you said about frustration and staying up until 3 a.m.,
Mm-hmm.
I feel like it can be, like, coding and programming intersect with mental illness in a lot of interesting ways.
Mm-hmm.
And a lot of sometimes very inconvenient ways because it can be like very pleasant to code, but especially if you have a mental illness that predisposes you to being self-critical or self-loathing or frustration could be more overwhelming.
Yes.
People, and if you have something like ADHD,
Right. Or OCD can interact badly. Yeah. Yeah.
So how do you stay aware of that, whether you are mentally ill or not, and how do you practice good self-care so that you don't burn yourself out or forget to do physical things?
Wow. That's a really good question. Yeah, can I just restate it for everyone? So the question is basically like, how do you practice good self-care so that in the course of getting wrapped up in coding and passionately following it, you don't say, get depressed, forget to eat, forget to sleep, like take bad care of yourself. How do you take good care of yourself is a really good question, and I think it's actually a much harder and more difficult question than how do you learn to code, which, and I see your hand too. Okay, I don't want to forget, but this is actually, you've done a nice segue to really my last thought. This whole talk there's a kind of a hoodwink behind it, which is that I've been talking as if learning to program is about your career. But everything that I just said about how things that aren't programming feed into it, learning to the letters of Paul, the art, the music, like that's all fed into my coding practice. It goes the other way. Coding is going to teach you things about life. Your question about self-care, like how do you take good care of yourself? That's not just coding, that's always, how do you know if you're in an abusive relationship? How do you recognize your own depression? Like those are life-changing questions. And I may be going on a limb here, but I think coding can actually help you find answers to them. The practice of working through frustration, thinking through things in a disciplined and hyper-precise way, working with others to turn human dreams into precise realities, that's education that goes beyond coding. And so my biggest piece of advice for what's the right way to learn and teach programming, don't think of it as just a career. Remember that programming is going to feed forward into your life in ways you can't anticipate either. And let the code be a part of your whole education as a person, because finally, I don't know if we're going to be writing code as we know it in 20 or 50 years. But I know that the things I learned from being a developer and working with people are going to be valuable to me in 20 or 50 years. I wanted to get to, your name is Adia on the end? Yeah. Hi. I saw your name tag. I'm not really that smart.
You pronounced it right. Thanks. So your question, there's
Yeah.
an amazing woman on Twitter. Her name is Julia. I butchered her name, and I just accomplished it. You get her Twitter handle is @flowerchild. Flowers spelled FLEUR. She basically tweets about the tech community and mental illness and how they intersect. She has a lot of great articles on how to deal with it, how she's dealt with it herself, especially being in more leadership positions. And she also has a bunch of positivity posts that she does all the time. So great person to follow.
That's awesome. What's the Twitter handle once more? @flowerchild.
FLEURCHILD.
Wait, so FLEUR, fleur, like the French. Yeah, no, that's all right. Like FLEUR, child. Cool. I want to just pop up here because it ties to what we were just saying. different kinds of education have different payoffs, and to Ian's point, they're all valuable. Learning a specific product has a short-term payoff, and it's worthwhile. Learning underlying patterns of software, that's why it's so much easier to learn the next language and the next language and the next language. When you're learning your first language, it's just like, what is this even? Where am I supposed to put the braces and the semicolons? Learning your 15th language, it's like, oh, I see. Non-escaping closures in Swift are kind of like blocks in Ruby, except that you can't return out of them, right? So what does that mean? It means that there's some pattern that I kept seeing over and over again, and every time I see it, it gets a little easier to think about it. Looking for underlying patterns is sort of what a computer science program is about. And so different kinds of schooling and education fall at different places on this continuum, right? And every kind of them can be valuable. Like if you're going to a 6-week code camp to learn a specific thing, that's awesome. That's a great use of 6 weeks. It's going to pay off for a few years. You should totally do that. Going to a 4-year, full college experience kind of program kind of hits all 3 of those, and if it's a good program, it's biased towards the 3rd one on the list. And if you're lucky, you get to underlying patterns of thoughts in life, like how do you take care of yourself? Those kinds of questions. How do you communicate with people? How do you achieve consensus? And also more abstract things, like how do you rethink a pattern in a way that makes it simpler? Like that sort of abstract metacognitive skill is something you can learn from software. It's useful in software, and that will keep paying off even after you're long done being a programmer if you ever stop. We have time, I think, for just maybe like 2 more questions if they're brief. Yeah, so wait, that was, you had your hand up first and you were super enthusiastic, I guess.
Excitement and money, that's way more useful to
Right. So the process of reflection, breaking it into parts, seeing the thing in front of you as it is, finding its underlying structure, and then changing your thinking about it. Yeah, that is squarely on the bottom thing in my list. Yeah, self-awareness is huge. I'm still trying to figure that one out. We'll get there.
So I want to talk about liberal arts.
Yeah.
I graduated from liberal arts college, so I totally agree with everything you said, which is awesome. But, I found this huge disadvantage for students who graduate from liberal arts college compared to students who graduate from college of science and engineering, when we're trying to find like I believe a point 3, get a problem work, get an internship, get a job.
Right.
I just feel like students who graduate from liberal arts college in the job market are much less competitive compared to those ones with hard science degree.
I don't think that's necessarily true. I know that many companies put a premium on hiring liberal arts students. Yeah, well, there was a New York Times article about Slack, how they made a point of hiring people with diverse non-programming backgrounds and looked for liberal arts majors, and that helped rocket them to success, and now everybody uses Slack. How did that happen? Because of all these great design decisions, because they have all this strength and aesthetics and theory of mind on their team. So it may just partly be about where you look. It's also my experience with liberal arts students, and we should talk more about this offline, is that liberal arts students are terrible at explaining what they have that's strong. If you don't have a bunch of really specific, impressive-looking, specific technical bullet points, and you kind of take it for granted that you're used to communicating clearly and working with people who aren't like you, then you have nothing to show in an interview. Whereas interviewers often looking at students are thinking like, oh, student joker, you've never done anything real, and look at this, you only have 1 language on your resume? Well, whereas if you come in and say, hi, I made projects with other people that I actually saw through to completion, and we had to think about novel and difficult things and synthesize information from many sources. They'll be like, oh, what, you're a student? So it's often just a way of explaining the strength of what you have. I don't know if that helps a little. We can talk more offline too. I don't want to run over time. You look very concerned in the back. Wait, how are we doing for time?
1 minute.
1 minute, okay.
A couple of things. One was about the whole thing about having the discipline to stop. Let's say you're working on a problem and not be tempted to work till 3 a.m. I think would help you. You need that speed.
Yeah.
So you're not going to be really productive if you're
Yes.
working till 3 a.m.
Yes.
Secondly, if you could bring up that list of just
Oh, I mean,
on
oh, yes, yes, yes. I'm so sorry. I'll just, yeah, there you go.
I was just reading a book by Josh Waitzkin. He's the guy who was chess grandmaster. The story was the story of searching for Bobby Fischer. He's written a book called Art of Learning, and many of these things are actually listed there.
Yeah.
Not programming at all.
Yeah, that's secretly programming is just sort of like a great liberal art to learn, which is kind of the attitude I think you should bring to it, whether or not you're actually in college. And just so a couple clarifications for the record: the desire to stay up until 3 is a sign that you should do programming. That doesn't mean that it's a good idea to always, right? You don't have to go to a college to get a liberal arts education. Just let's be clear about that. College is great for some people and terrible for others, and either way can work. And finally, to your point, I work at Bust Out Solutions, where I do a lot of freelancing. I work with some awesome developers, and only 3 of us of the dozen or so are computer science majors, and one of the CS majors is actually a designer and hardly writes any code. The other developers majored in anthropology, philosophy, Spanish, I think, biology, and learn coding along the way. That can be a great way to get an education. So don't I had that continuum of short and long-term payoff. Maybe you need, as a liberal arts graduate, maybe you need to focus more on getting some things with short-term payoff as well. If you've done a code camp, maybe think about what you're missing on that list on the long-term end. Whatever part falls inside or outside of the school bubble, just make sure that you're covering that whole spectrum of learning, short-term and long-term things. I need to stop there. Thank you all so much. It's been a pleasure.